Hello, everyone. The aim of this talk will be to define the concept of soil health and discuss how it can be measured and evaluated. So I want first to thank all the colleagues that are involved in different EJP projects, and as we developed all together this first talk. So thank you all for that. And so I'm presenting you the work of several colleagues. So first, in EJP, within the different projects, we propose several definitions, and for example, for soil health and soil fertility, and many other terms. You see in blue in the table different terms that are defined in different documents coming from the SIREN project or SERENA project. So, for example, we define soil health as the current capacity of a soil to function as a vital system, as a vital living system, with natural or managed ecosystem boundaries and land uses boundaries to sustain plant and animal productivity and health, maintain or enhance water and air quality, and further provide ecosystem services on the long term without increased trade-offs between ecosystem services. So it's a definition that was started and then adapted by SERENA project. It was defined first by the SIREN project. And what is important here, you will see in the next slide, it's the current capacity. I will come later to that. We also define the soil fertility. I will not read the definition, but we define different terms in the project. And something quite important for us is that in fact soil health is not equivalent for us to soil quality, and we developed the following figure to explain the differences between we think between soil quality and soil health. And we see in fact soil quality as the capability of the soil to support in a sustainable way to support the ecosystem services, and it's based on the soil properties. And then soil health, as just said, is seen as the current capacity of the soil to support the ecosystem services, meaning that soil degradation, for example, or non-adapted management practices or climate change can limit the ecosystem services provision according to its capability, in fact. And of course, you can also increase the capability of the soil, produce more ecosystem services, but then you may have trade-offs on that. So it may become an unsustainable situation. So that's the way we see the difference between the soil quality and soil health, meaning that quality is a capability of the soil to sustain, to deliver ecosystem services. And so the soil health can be seen as a capacity, a current status, a current situation. So there's a difference for us between soil quality and soil health. We also define other terms like indicator, and we see indicator as a single or set of variables to represent or infer a specific aspect of soil health. And the indicators can be measured using classical analytical protocols, estimated through modeling or expert-based approaches. And then, of course, they can be quantitative, semi-quantitative, or qualitative. And we also define several evaluation criteria as reference value, target value, and threshold value. And so a reference value is a value for an indicator representing its normal background value for defined local circumstances. And you can consider it as equivalent to normal operating range. That it's also another way of saying reference value. Target values represent the desired status of a particular indicator or set of indicators giving specific ecological conditions, land use, and objectives for use. And it's given usually by authorities or other stakeholders. And the threshold is seen as a value above or below which soil health or soil quality is considered to be degraded. So that's the first part on definitions. And then coming to the selection of relevant possible indicators to evaluate soil health or soil quality, we discussed several ways. And we first suggested a top-down approach. And in that top-down approach, we start from the needs, from the policy needs. And here there's an example where if you consider different policy needs for desertification and climate change and food security, then we look at what is needed as what are the ecosystem services that are needed, that are requested to support those policies. Then here, for example, it's decomposition and fixing processes linked up to climate change. And then you look at the soil functions that are supporting those ecosystem services. And here it's natural soil fertility and balance of soil organic matter mineralization versus humification. And then what are the soil processes behind? And based on that, you can choose several indicators, biochemical, biophysical, or physicochemical indicators that will support, in fact, the functions, services, and finally also the policies. And again, this is how we define soil quality, integrating those different aspects. And while thinking about that way of selecting indicators, we end to the conclusion that a guidance is missing to help us to do that. Whereas there is a guidance, for example, an ISO document, a guidance to select indicators for ecological risk assessment. But there's now an ISO working group on that work that is currently trying to draft that guidance. We also made within SIREN and SERENA, we also made a survey within EJP SOIL members to stocktake all the quality indicators used in the countries participating to the EJP SOIL program. And we got several answers, and those answers are summarized in that figure. All the indicators used in the different countries are grouped here by categories. You see that you have indicators for organic carbon, for adsorption complex, for nutrients, indicators that report on physical characteristics or on soil water content, on structural and physical degradation or chemical degradation, biological parameters, for example. So from those 68 indicators, we then group them, and then we identify the top 3 indicators. So the top 3 indicators are carbon, the measurements that report on the carbon status of soils. So it can be carbon concentration, carbon stocks, the organic matter quality, soil organic matter decrease, for example, or carbon balance in biomass and soil. So different kind of indicators reporting on carbon are used in the countries. You have the number of countries. The y-axis is on the number of countries using the indicator, and the indicators are written in the x-axis. And you can note that biological indicators, for example, are largely missing as indicators also on organic contaminants. And so we try to define a minimum data set of indicators for monitoring soil quality across Europe. And so to make that selection, we decide to cross different criteria. And first criteria, remember the top-down approach, where those indicators should be policy relevant. They should be inform and help policymakers. So first criteria, it should be relevant to policy. Second criteria, it should be used at least by 50% of the countries, meaning that they are already implemented in several monitoring systems. So we choose that as a second criteria. And then the third and fourth criteria where that they should be used in the literature and recommended, and also applied and tested in several EU projects. So when you cross all those requirements, you end with the following table. The first column is about the policy relevance of those indicators. They will report on the soil physical conditions, on the soil fertility, on the erosion, on salinity, on contamination, and on soil biodiversity and water regulations. These are the main issues raised by the different policies. And then you have the possible soil quality indicators, and you see that for few ones we are missing because they are not used in at least 50% of the countries. The first ones on texture, porosity, or carbon concentration, for example, they are already implemented in national systems, whereas organic contaminants, soil biodiversity, and water regulation are not. And so we recommend to include indicators dealing with organic contamination, soil biodiversity, and water regulation. We recommend to include that in a first year, plus the other ones that are more or less already used in the countries. And for biodiversity, we recommend also to collect data on structural and functional biodiversity. So last part of the talk will be on the different ways of interpreting the values, how to set target or threshold values. And so we all together identify 4 main ways of deriving such values. The first one, quite simple, is to use a fixed value, one static value based on the best available research knowledge. And of course, you should also maybe stratify if required. And for example, as an example, you have a table that is proposed by a recent EEA report that proposed values, soil organic minimum values and maximum threshold for cropland in soils in Europe. The second way of providing threshold or target values is to use modeling and to try to have as an objective a natural situation, a natural land use that could be, for example, a grassland, and then you use a model to predict what could be the situation if you change the land use, if you have a grassland, and you set a limit. For example, 60% of that maximum will be your target value, and it's based on a modeling approach. The third one, in that third one, so you have a graph for that modeling approach. So you can say that you need to reach at least 60%, for example, of the natural situation. The third way of deriving such values is just to give a relative change, to ask for an increase or decrease of Y% in the coming 5 or 10 years, for example. So you ask people to look at their soils and to increase one property, one indicator of Y%. So it's more local, for example, and it can be local or even at national scale. You can ask to increase by 5%, 2%, a specific parameter of your soils. And the last one is it's a data-driven approach. It's based on a distribution. So you need for that to make to collect data on a specific area, and then you have a distribution of a specific parameter. It's, for example, a soil organic carbon, and based on that distribution, you select a centile, a certain percentile that will be your threshold or your target value, and this is static, of course. But then if you remeasure it for 10 years after, of course, the distribution will change, and you can also change your target after that. So you see different ways of developing developing threshold or target values. And we also try to identify advantages and constraints linked to those different ways. And for example, for the fixed value, well, it's quite a simple way of communication to communicate the results. It's easy to understand. You have one threshold, you are about or below, but of course, to do that, you need to stratify according to land use, soil types, for example. And so you need a lot of knowledge for that and a lot of data also. And you also need a sort of a consensus between scientists to select the data. The second one, of course, if you have a proper model, it could be quite easily to set those target values. But then the difficulty is that you need a model. You need a model for different parameters. If you set, if the situation is the natural land use, then at least in Europe, a lot of landscapes are managed, a lot of soils are managed, and so there are not that much natural land uses that can be used as a reference. And it's more difficult to explain that than a simple and than a single value. Well, the relative change, it's a quick way to start and look at the trends. It allows also the differentiation between due to diverse pedoclimatic conditions. And it can be also used locally for advisory services to help farmers. Of course, one problem is that if you have done very well, if you reach already the target, then it will be difficult for you to improve. Then if you have done well, it's more difficult to improve then. And then you may have also, if you want to make aggregations and make maps, then you will need to consider also, because you have two temporal analysis, you will need to consider that variation in time. And the last one for distribution, well, it's quite adapted to pedoclimatic conditions, because you can stratify your data according to different districts, according to land use, soil type, and climate, for example. But of course, to do that, you need a lot of information, a lot of data to develop those statistical distributions. And another point is that the area is already degraded, then your information is biased, because your distribution will be pushed to low values, for example, and then the target you are setting is already a degraded situation. It's not, let's say, a normal or a median situation. It will be a degraded situation. So we need to take care of that. And the colleagues from Italy already tested are starting to test those different ways of deriving thresholds and target values. And so on the left part of your screen, you have they apply the EEA threshold values. So the table I show you at the beginning that are stratified according to soil texture. And so you see in red the degraded areas. And if on the right side of your screen, they use a reference to natural land uses, to grasslands, and they set a threshold at 60% of the mean of soil organic content in meadows, and you see the difference. You have less red-colored areas, so that means that depending on the choice of your method to derive or target or threshold values, you may end with very different situations in your country. So yeah, we need to think about that and think about how to derive those target or threshold values. And finally, I will end with I try to set the scene, the current scene of this issue of selecting indicators and providing target and threshold values. And just to let you know that we talk about the SIREN project that is currently finished, and we have the report available, and also the EEA report on soil monitoring in Europe, and that also propose indicators and thresholds for soil health assessments. So these documents are available. Still running the EJP SOIL projects, Monitor and Serena. You will have a presentation just after of those projects, and still running also the work package 6 of EJP that, and we deal with the development of indicators and thresholds, and we are currently drafting a guideline for that. And everything is now feeding the European Soil Strategy, the European Soil Law, and the European Soil Observatory. And remember that just starting now 2 other projects from the EU mission that are starting, Benchmark and All for Soil. So 2 projects that will also update our vision on indicators and thresholds or target values. And finally, every reflection should also help the building of a new indicator that is now proposed by the Global Soil Partnership on soil indicators. So the story is not finished. There is a huge place now still for research. So a lot of work is still under progress from EJP SOIL, but also from other projects. So thank you for your attention. And if you have questions, my colleagues will help me to answer.
Yes, Antonio, we are receiving a lot of questions.